All right, everybody. Welcome out to podcast number 441. I've got Mr. Montero here with me again, and we're going to again go through the book Elevating Construction Surveyors, which will be out in the near future as we create it together and do this in kind of a fun way. Stay with us.
This is the Elevate Construction Podcast, delivering remarkable content for workers, leaders, and companies in construction wanting to take their next step. Get ready to step out of your comfort zone with Jason Schroeder as he encourages you to do better, live a remarkable life, and expect more. Let's go.
Welcome, everybody. Hi, say hi to everybody, Mr. Montero.
Howdy.
I love that. And we're going to get started right away. So in case you weren't with us in the last episode, Mr. Montero and I are audibly going through and creating portions of the draft version of the book, Elevating Construction Surveyors. Sorry. And he is telling stories, and we're talking on the audio so that we can transcribe that to text for the draft version of the book, which we had promised to a number of listeners and fans of the Elevate Construction journey. So we're going to get right into it. So number 6, learn the math. Math is a fundamental pillar of surveying. Although surveying equipment and data collectors perform much of the math on their own, understanding why or how the math works allows you to envision each step in the process as you perform it. It allows you to plan the next step ahead of time. Remember, the data collector and our office calculations are not foolproof. If data was misentered into the office, would we be able to spot errors in the field if we couldn't envision the math? If we weren't considering what the general results should look like in our head before the data collector spits out its results? Understanding the math gives us that additional layer of QC at any time because we know how to check our results ourselves and by hand. So, Mr. Montero, this is a great subject that I hope a lot of people can buy into. What is your story for this one, my friend?
I remember a case of property corners being set in the wrong place on a particular job, and going back to the field book of the crew lead that had laid them out. This story actually, unfortunately, is rife with missteps, but we'll just talk about the ones that apply. So one of the processes was to turn doubled angles for each property corner to make sure that our initial turned angle was correct, and that it was set with precision. I remember being in charge of QCing or trying to troubleshoot what had happened out there. And one of the first things that I noticed was that I couldn't get the math to work out for these doubled angles. So I called the particular party chief, and we talked at the end of the day, and it turned out that he didn't know the math for doubling an angle and how it should look in field notes. He just knew that we required him to do it. So he was just writing down literally his first turned angle and then just some other number in the book. As a result, one of his primary angles, or his first angle, several of them actually were turned poorly. Some transposed numbers, I'm assuming, in his head, and then there was no back checking math that would have alerted him of anything, when comparing to the data collector. The problem there is, number one, not knowing the math. Math is huge. It's huge in surveying. It really has everything to do with every single thing that we do. There's a lot of ways that we're creating math physically, like pressing offset on the data collector or drawing a line and snapping to perpendicular in AutoCAD. That takes the thought process out of our hands. But if we understand the math, when we see an error happen, we'll know, because we can look at the numbers and say, this math doesn't add up. Something is wrong. What is it? If we don't know the math, that will never trigger. And things which are performed incorrectly will just slip by us constantly through the course of our career.
I love that. So I wrote down the quote Excuse me, one second. Oh, I thought I was going to sneeze.
Do it.
Oh, there we go.
And you nailed it.
Thank you. If we don't know the math, we will not be able to check the math. That's the quote I came up with. So if we want to change that, we can do that now or later. But let me ask you, Mr. Montero, what would be the concept that you would want to describe, or even the challenge? Maybe you've already explained the concept, but what would be the challenge at a minimum here for this?
The challenge at a minimum would be to you have to want to get better at things in your career, and sometimes that means either doing additional work outside of the workplace, or taking the lead and being the person who carries out those math functions or performs QC while you're out in the field, so that you have repetition, and learning a particular subject or topic. And math is just one of those topics. So if you're a person who's, at the Rodman level, or I would even venture to say at a crew lead level, and you don't know the math for the particular task that you're carrying out, you're depending on the data collector to do it, or you're depending on AutoCAD to have thought through the process for you. My challenge would be find out what the math is and QC your work at every possible step. It should just be part of our standard function to know the math and to QC our work in accord with that math.
I love that. Thank you very much. Let's go on to number 7. Learn to use the equipment. Once the above components really begin to take shape in your mind, understanding the case use of the equipment is the next step. Which equipment is right for each task? What are the best practice methods for using each piece of equipment? How do you use the equipment to QC your work? Taking time to perfect the basics like instrument setup, using the hard sites, updating settings like temperature and prism constant as needed can't be overstated. This is where your previous work of envisioning the tasks and picturing the math in each step will catapult your ability to be a competent instrument operator. Don't be content to let only what others tell you define your experience. Look for instructional videos, download and read instrument manuals. Always have room or take room or keep room to broaden your knowledge and to grow. So, Mr. Montero, what would be your story for this one?
I'm going to disrupt the flow just a little bit, but I'll put it right back on track. I want to return to one thing that I was thinking on the last topic, and that was the work is done once the math checks out. The work is not done when you're finished performing the task. And that is just a really important concept. I've seen so many people run level loops and just come back with math that doesn't check out. And essentially, the work was completed for nothing. So looking for those double check methods that tell you this math checks out and the work is done entails you knowing the math. In the same way with the equipment, if you are planning what's going to happen on a project, if you're planning which equipment is going to be used, even if you're at the level of loading the truck, okay, what needs to go out with us in the field on this particular day? You have to know the capabilities and methods or the reasoning behind using different pieces of equipment. There is something right for each task. And there is a way to QC each piece of equipment as well. And if you don't know what that is, or if you haven't looked into it, if you're not on the learning curve already and trying to understand what that is for each piece of equipment, it will be easy to miss that. In the text there, I talked about taking time to perfect basics like instrument setup or using the hard sites. So along with knowing how do I technically use this equipment, also, now what's the fast way to use it? What speeds up this process? Or, if my mind is constantly in the on position and I'm paying attention, is this step in my setup really necessary? Or, am I creating rework? Again, not being content to observe and watch, but to think about the process yourself in the way that you learn. Is there a better way? Is there a best way that I can do this? Always room to grow.
I love that. So we're going to come up with a better quote here, but I put down learning the equipment is a crucial step in perfecting your practices and your professional development. So what would be a challenge that you would give us as we close this one out?
A challenge that I would give you, well, what does continuous improvement look like and how do you measure it? So if you're a rodman who currently sometimes sets up the instrument or is in the process of learning how to set up the equipment, time yourself and then beat your time and then beat your time in a few more months. As you're doing things, think about how long did this step take or what did I have to redo? And think, well, what would make that better so I wouldn't have to redo it in the future? I would say challenge yourself, set metrics, know how long what you're doing takes, and challenge yourself to beat your own time so that you know I am improving in the way that I carry out these tasks. I'm not just thinking I am or wanting to, I'm measuring it.
I love it. Let's go on to number 8. Learning note keeping. This is a big one for me. Let me read it. Our notes are often the only record of what we truly accomplished. Though the data collector often logs store point values, our notes can contain infinitely more detail, such as fuller descriptions, instrument and rod height revisions, sketches to help us understand how the work was carried out. Our notes may even ultimately act as the exhibit which is shared with our project team or trade partners. Clear notes and clearly stated values are just as important as following the correct formatting so that other people who are reviewing our work can understand what they are seeing. Make sure to take time to take good notes and create thorough sketches in the way you plan your work for the day. So do you have a metaphor or an example, comparison, reflection, or a story for us for this one?
Well, I teach surveying at ASU as part of the construction management course. And I have seen field notes from the most beginner level to an intermediate level. And I would say that a lot of failures to complete a task come from not really knowing how to keep notes. They didn't have enough information to start with on what the task was or what some of their starting information or data might have been. They didn't format the notes correctly, so it made it difficult for them to perform math because they didn't know which numbers they were comparing. The way that we store our information out in the field is everything, and so note taking should be really one of the most fundamental concepts for a surveyor. There are lots of different tasks that we do, whether it's 3-wire levels, turning multiple angles for traverse work, monitoring over the course of time. Whatever it is, there is a particular note keeping style that will make sense, that will be the easiest to read, and that can be understood by others. That means sometimes we're going to use predetermined formats that are, make sense to the industry already. Or if we're doing a new and unique task, we'll be arranging things in a way that would be clear for anyone to be able to understand or really follow what our thought process was.
I love that. Always keep good notes.
I would add to it really quickly from an exhibit standpoint, a great set of notes is your exhibit. Could potentially, remove 2, 4, 6 hours of CAD work on the back end of something for somebody to put together a great looking exhibit. If you had all of that math already in your notes, all of the results, and a great field sketch to go along with it, sometimes that can be presented right to the project team and save hours of future drafting work. If it's not something that's already in the budget.
I love that. Excuse me. Sorry. Is there anything from an application or challenge standpoint that you want to give us before we leave that topic?
Yeah. If there are particular note keeping styles that you're not comfortable with, make sure you're the one taking notes. I like the metric of if something is scary to you, it means that it's a growth area. So if you feel not capable in a particular area, chase that area down until it belongs to you. Plenty of tutorials online. Look up particular note keeping style just by typing in the type of notes that you're taking in a Google search, and really just get familiar with what's out there for you. Plenty of references online.
I love that. That was a great section. So important. And it can't be ignored, especially in this day of technology. So here's number 9, getting right into technology. Learn Civil 3D or CAD. A well-rounded surveyor is one who can knowledgeably carry out the largest variety of tasks. CAD work goes hand in hand with our product out in the field. Often the base drawing setup, point calculations, and staking exhibit are performed in the CAD environment. When our work comes back from the field, it can be QC'd in CAD or as-builted or as-built and topographic mapping needed to be drafted out and added to our base. That makes the field 1/3 of the process of completing any basic survey function. Why limit your knowledge and experience to that third? Even in cases where we won't be the final or primary draftsperson, understanding the needs of the draftsperson will often change the way we record data. We'll truly understand what is needed to turn our work into a final product, not just check the box of accomplishing the field work. I really like this section. Any stories, reflections, or case studies or metaphors for us?
Yeah, I have a good reflection. And even before thinking about learning AutoCAD as a drafter, I would say that for a person, a capable person in the field, you have to have an understanding of AutoCAD. When you turn in your work, specifically if you're, turning in as-built or if you're turning in topographic data, you have to understand that even though a civil engineer is going to design a site on top of what you turn in, what he's actually going to design the site on is the topographic map created by his drafting technician. He's going to look at that data and go from there. He's not going to see your points. He's probably not going to review your field notes. So your client then is the draftsperson because he needs to turn that into a product. That product is going to be used by the civil engineer. So the civil engineer is the client of the draftsperson. I would think of it that way, or I like to think of it that way, because that means I need to do everything possible as a surveyor to make sure that the draftsperson renders my work perfectly. I make it the easiest for him in the way that I think, in the way that I code and label things, in the way that I connect lines or draw a sketch or take photos to enable that person. So I'm thinking in my head all the time, how will he draw this in AutoCAD? That means that I myself have to have an understanding of AutoCAD as much as possible. So again, I recommend learning the platform itself. So that's where I start from a conceptual standpoint. Do I understand AutoCAD well enough to know how will this person draft? If you're as building a wall and someone is going to build a surface from that data, do you know how it needs to be drawn so that the surface can render itself? There won't be crossing lines. The draftsman doesn't have to do a bunch of rework. Those are all things that can be understood by the surveyor. And I can tell you right now, from talking to so many people across all kinds of different disciplines that work with draftspersons, that information is not making it from the field to the drafter. The surveyor goes out and does surveying, and he's thinking about surveying, and the draftsperson looks at it as a drafter and is just like, what is this data? Why don't these lines connect? Why isn't there enough for me to draw a fixture or this structure or create a surface? It's because those two don't know how to communicate to each other. So a great way to do that, get your hands dirty yourself. Go practice topographic surveys, take your own topographic work home and try to connect all of the dots and see if it makes sense to you. Could you even recreate it? Not just from your mind, but with the data that you collected. So there are lots of little ways that you could challenge yourself. I'll fill in that section right now. Take your own work home, create an exhibit from it, create a topographic map and a surface. Again, there's lots of training that's available online. So those things might sound a little scary. Creating a surface from point data takes about 5 minutes. That's without touching it up to make sure that it's perfect. There are a lot of things that you can just kind of, you've heard like cut your teeth on or whet your appetite on that will set you down the path of understanding how to use AutoCAD, number one, but how to communicate with the people who are actually receiving your work, number two.
That was brilliant. Let's go on to number 10. Because I think you covered the quote and the challenge right there at the last, right?
Yeah, I was getting long-winded. I could tell, so I tried to knock out a couple of the other things.
That's okay. Let's go to number 10. Overcoming the error in basic tasks. Error creeps into everything we do. It's unavoidable. Human error, instrument error. Fortunately, the right system of best practices will foresee and balance out the error we encounter. This takes forethought and envisioning the process. If we can determine areas where the most human error creeps into our work, we can use different methods or tools to accomplish that component. If we are aware of our instrument's capabilities and understand its inherent error, what best practice, what step will allow us to average that error out or alleviate it altogether will become clear. By rejecting the idea of good enough, we'll be on the constant lookout for ways to improve the precision, speed, and accuracy of our work. All right, Mr. Montero, so what reflection, metaphor, story, or concept would you like to share with us to introduce us here?
There in surveying, specifically in boundary surveying, there's a phrase, it's on the cap. That means that as long as your measurement falls somewhere on the cap set by surveyor, that you don't have to on the map report that this thing is out of position. In some places, that's a real easy summary, and obviously there's a little more that goes into it. But did you as built or locate this thing and you fell somewhere on that cap? Okay, it's acceptable. How often do we do that? It's acceptable, it's good enough versus this is the true measurement or this is true accuracy. Obviously, there's a time and a place for it. But in our work, there is error creeping into everything. Some of that error is associated with the rod, the way we're holding the rod. Are we leaning over the bubble enough to look down and know that the rod is plumb? Has the rod been calibrated? Some of the error is coming from the instrument. Is it a 1 second gun, a 2 second gun, a 5 second gun? All of those things matter. Do we have the correct temperature in for the way that it's measuring presently? Or is that creating error? Those are things that we have to think of if we are performing work that requires us to be extremely precise. We don't want to just go with good enough. We don't want to just accept what the instrument is telling us. And what I mean by that is, if you have a 5 second gun and you turn an angle and the angle says exactly 90 degrees, well, isn't that up to 5 seconds off of 90 degrees, simply by construction of this piece of equipment? So is there a best practice that could alleviate that? Or from a measurement standpoint, is there another tool that we could use to back up our measurements? Just all of those things. How do we overcome those errors? What's the best practice that allows us to do it? Or can we alleviate it altogether? Like in the case of the rod, okay, you've got the 6.5 foot rod that's introducing a certain amount of error into every measurement that you take while you're laying out a building to better than 100th. Can you get down on the ground with a mini prism? Can you make sure that you're sighting line at the ground instead of at the prism so that you know that, the actual object of measurement is the same as what you're laying out on the ground, which would alleviate the error completely from an angular standpoint. So just thinking about those things as we perform our tasks. Again, not just performing them, not turning our brains off, but thinking, how does what I'm doing introduce error? Is there a better way? Is there a way to alleviate this? What am I doing with each task?
I love that. And the quote that I wrote down, it's on the cap, is not a good measurement for a professional surveyor. We target the right measurement, not just good enough. Ooh, I kind of did a good job with that one.
I do like that one.
All right. So that's up to 10. So we've done 5 more. So we're going to keep going. Mr. Montero and I may do another section right now, or you may hear from us in about a week. But for those who might be listening to this podcast, if you have survey professionals, field engineers, foremen, anybody involved with these things, these concepts don't just apply to surveyors. In fact, that's probably the most frustrating thing about everything that we do at Elevate Construction is like, if we write a book about supers, 90% of the concepts apply to project managers, so we have like a marketing problem over here because these are like universal truths. But anyway, this is section numbers 6 through 10. And let's go ahead and say goodbye to everybody for this the next little section. We'll go 1, 2, 3.
On we go.
Please join us next time in elevating the entire construction experience for workers, leaders, and companies coast to coast. If you're enjoying the show, please feel free to share with your construction colleagues and help us spread the word by rating, subscribing, and leaving a review on your preferred podcast listening platform. We really appreciate it. We'll catch you next time on the Elevate Construction Podcast.